Hi, this is the demo of DDGen, a software tool from Vayavya Labs Private Limited. DDGen is a tool that automatically generates almost complete device drivers based on two input specifications. The two input specifications are device programming sequence or DPS and runtime specification or RTS. As of now, DDGen is a command line tool. On command line, to specify the input DPS file, the -E option is used and the -S option is used to specify the RTS input. The tool runs in an interactive mode, allowing the user to make some modifications to the generated code. A list of features or programming sequences specified in the DPS is listed out, and the user can edit a file called Vayavya flist.txt during tool runtime to modify the names of the features or to deselect some undesired features. The user can decide on which all interrupts are to be enabled by editing a file called Vayavya int list.txt during the tool runtime. Let us now take a look at the input files and the generated output code. We will first take a look at some of the specifications in DPS. This DPS is for Intel's 82567 gigabit Ethernet card. As can be seen, DPS supports C-style multi-line comments. It also supports a couple of other types of comments like C single-line comment. The include directive tells the tool to include the specified file as part of the compilation process. This can be used to modularize DPS, and it is usually used to write the device register specification in a separate file. Register specification. Registers are classified as control registers, general purpose registers, interrupt registers, etc. All the registers belonging to a particular class will come as a part of a block that is started by a keyword, followed by an opening curly brace and ended by a closing curly brace. The keyword will indicate the class of the register. Each register specification consists of its name, size in number of bits, and its offset from the first register. The size is specified inside a pair of square brackets, and the offset is preceded by the @ symbol. All other information pertaining to a register will be part of this block. This information consists of the following: the mode in which the software can access the register. It can be read, write, or read-write. What should be the value in the register when the device is reset. A brief description of the register, which will be printed out as a comment in the generated output code, and information about all the fields. The specification for a field in a register consists of the keyword field, followed by the name of the field and the low bit and high bit positions of the field specified between a pair of corner brackets. The rest of a field specification is specified inside a block. This information consists of software access mode for the field, how the field should be cleared, and a brief description about the functionality of the field. Again, the description will be dumped as C comment in the output code. In case a register or field is not meant to be accessed by the software, the keyword reserved can be used to indicate it. Device specification gives the tool information about the name of the device class to which the device belongs, etc. The descriptor spec gives the tool information about the type of descriptors supported by the device. This specification is required when the software has to provide the device with buffers. There can be separate specifications for transmit and receive, or there can be a single specification in case common buffers are used for both transmit and receive. The information provided by this consists of how should the descriptors be iterated through: a circular array, a circular linked list, a plain linked list, etc. Where should the memory be allocated for the buffers? How should the start address of the descriptors be provided to the device? Which field in the descriptor should contain the address of the buffer? How should the software know whether a descriptor is available for use by the software? Where should the length of data be stored? Which field contains the status of the descriptor after transfer? The buffer spec provides information about how the software should allocate buffers, whether it should use memory inside the device or the system memory, and what should be the size of the buffer, etc. The interrupt spec provides the tool with information about all the interrupts supported by the device. A device can support different types of interrupts like normal, otherwise known as legacy, MSI, or MSIX. There can be different interrupt lines for different interrupts or a single line for all the interrupts. In either case, each interrupt line is identified by a name. The interrupt spec has some global fields that are applicable to all interrupts and some fields that are specific to each interrupt. Each interrupt is identified by a register field and an associated value and provides information like the type of interrupt, how to enable the interrupt, how to disable the interrupt, and how to clear the interrupt. If an interrupt is further multiplexed, then source field specification provides language support for specifying it. There can be specifications that are particular to the class to which a device belongs. Network class devices will have Ethernet spec to provide information such as what is the MAC ID and whether the device supports auto padding, etc. Bus spec provides the tool with information about the types of interconnects supported by the device. If it is a PCI device, some PCI specific information has to be provided. Features are different blocks of programming sequences required for the correct functioning of the device. A brief description about the feature can be provided just before the start of a feature. Depending upon the class of the device, some features are mandatory. All other features are optional and their names are not keywords. Features are specified using the keyword feature followed by an identifier, which is the name of the feature, and a block containing the actual programming sequence along with the input-output arguments and local variables. The programming sequence supports various kinds of operations like assignments, relational operations, arithmetic operations, bitwise operations, etc. The with keyword can be used if different fields of a single register has to be written to simultaneously. Two features are mandatory in case of devices belonging to the network class. One is pre-transmit, and in this example, an input argument specification can be seen. Further, in this feature, there is an example of the third type of comment supported by the tool: comments starting with the hash or pound character. Such comments are dumped as C comments as mentioned in case of description. The other mandatory feature for network class of devices is the post-receive feature. The RxOK feature demonstrates the use of bitwise operators and relational operators. There are two programming sequences identified by two keywords, init and finit. Init is the programming sequence that must be executed when the device is being started up. Similarly, finit is the programming sequence to be executed when the device is being shut down. The poll keyword is a programming construct that will result in the generation of a while loop that will keep on looping until the condition specified as part of the construct is satisfied. Now, a brief look at RTS. The runtime specification provides the tool with the necessary information about the system or software environment. RTS code, the demo of DDGen by Vayavya Labs is complete. Thank you for your patience.